Tonight on Top Gear, we try to look cool. Margarita gets excited.
Hit it, hit it, hit it, hit it.
And Dr. Professor Andy Christopher teaches us about physics.
Tonight on Top Gear,
we were able to get the 2014 Guillotine.
Lovingly nicknamed the Guillotine, this car was made from only the finest plastic tub from Walmart. Its wooden frame raises to a stunning 1.25 meters, and its wheels were said to be imported from the Ferrari stockhouse.
the vehicle moves when the string attached to the bar of springs is wound around the axle. The sandpaper creates friction, so the string does not slip on the axle, but it can be semi-dangerous.
When released, the car accelerates to a considerably fast velocity. It needs this speed in order to have momentum because its design is so light. The springs contracting apply a force to the string, which in turn applies a torque to the axle, making it spin.
The elastic potential energy of the spring converts to kinetic energy, driving the wheels in a rotational motion, and that applies a backwards force, sending the whole car in a forward linear motion.
While Margarita was explaining all the boring stuff, I went to go find the racetrack to test drive it.
So the car has big wheels, which is bad because it takes more force to move it, but it's good because it adds more momentum to the car, which we need because the car's very light, so it doesn't have a lot of momentum. So we use the big wheels on the back axle, and the back axle is really big. It's got a huge diameter, which is awesome because it doesn't take as much torque to move a bigger axle, so our car works better that way. Also, for springs, we used 4 springs instead of 2 because 4 springs adds more potential elastic energy, and the more potential elastic energy we have, the more kinetic energy we'll have. And so we also stretched the 4 strings all the way down to the bottom because that adds more elastic energy too, which will add more kinetic energy later.
To test the car, we handed over to our tamed racing driver. Some say he only ponders physics, and that while he does it, he's standing on his head and doing jumping jacks. All we know is he's called the Stig. It starts off strong. And across the line. Next up, our celebrity guest teaches us about physics.
So, Dr. Professor Anderson Christopher.
Please call me Andy.
So, Andy, how do the springs work?
So the springs work, so when they're stretched out, they have elastic potential energy. And so by attaching the string to the end, when it pulls the axle, that elastic potential energy is converted into kinetic energy, which helps the wheels to move. So when we add more springs, it increases the elastic potential energy, which increases kinetic energy.
So why add the weight to the car?
Adding the weight, so without the weight, our car flipped. So by adding the weight to the car, it increases the normal force, the gravitational force and the normal force acting on the car, so it keeps it down on the ground and increases friction between the ground and the wheels so that it doesn't flip and that it goes straight.
So how do the wheels move?
The wheels move by, so when this, as before said, the springs, so when the string is pulled, it adds torque onto the axle, which causes it to rotate. And when the axle rotates, the wheels rotate. So then that makes them start to roll. But as the wheels move, they have friction between the ground and the wheels itself, so that it is able to stay on the ground and move forward.
Awesome. You drove this car on the bowling pin track. How do you think you did?
I think I did pretty well. The first 2 runs were more so experimental, but from those 2 I learned that in order to increase the speed of our car, we could use more springs to add more kinetic energy. And to make it go straight, which we had some problems with it curving, to make it go straight we tried to center the axle so the wheels were even on either side.
Well, let's see how you did. You knocked down 13 bowling pins and went 32 meters. that bombshell, we'll see you next week.